Triangle. It's a union of three line segments determined by three non-collinear points. And you know that three non-collinear points, they determine a unique plane. That means a triangle is a planar figure. Supposing P, Q and R are three non-collinear points, then triangle PQR can be represented in set notation like it is a union of line segment PQ union line segment QR union line segment RP. That means a triangle PQR is a planar figure which is formed by the union of three line segments, and these 3 points that are given should be non-collinear points. For triangle PQR, the points P, Q and R respectively, they are called as the vertices of the triangle PQR. Whereas for triangle PQR, there are three sides, that is line segment PQ, line segment QR and line segment RP. They are called the sides, and the sides are the subsets of the triangle. Whereas it has got three different angles, that is angle PQR, angle QRP or angle RPQ. In short, respectively, angle Q, angle R and angle P. They are the angles of the triangle PQR. But the angles are not the subsets of the given triangle. Only the sides are the subsets of the triangle. That means the triangle has got 6 parts, that is 3 sides and 3 angles. So there are 6 elements of a triangle, 3 sides and 3 angles. What is the meaning of the word included angle? While we refer to the 2 sides of the triangle, the angle which is represented in a single letter notation by the point of intersection of these 2 sides, that angle is called as the included angle of the sides, or as the included angle of 2 sides of the angle whose arms contain both the sides as the subset. For example, for triangle PQR, if we consider the angle included between line segment PQ and line segment QR, that will be angle Q. Why? Because you can see that Q is common to both the sides. Similarly, the angle included between line segment QR and line segment RP will be angle R, and between line segment RP and line segment PQ, that will be angle P. Exactly the same way, the side opposite to an angle. The side opposite to an angle of a given triangle is nothing but the side other than the sides for which the given angle is the included angle. It is a side which is not the subset of the included angle. That is what we can mention. For example, for triangle PQR, what is the side opposite to angle P? That will be line segment QR. The side opposite to angle Q would be line segment RP, and the side opposite to angle R would be line segment PQ. The angle opposite to a given side. The angle opposite to a given side is the included angle of whatever the remaining sides. If I give you for triangle PQR, the angle opposite to line segment PQ, that will be angle R. Angle opposite to line segment QR, that would be angle P. And the angle opposite to line segment RP, that is angle Q. So, we can write down the names of the angle opposite to the given side very easily. Included side is nothing but the side which is included between the 2 angles, and that is opposite to the remaining angle. That means whatever the names of the angles are given, whatever the remaining name, the side opposite to that would be considered as the included side. For example, for triangle PQR, the side included between angle P and angle Q, that is line segment PQ. The side included between angle Q and angle R is line segment QR. Whereas the side included between angle R and angle P is line segment RP. So in order to write down this type of answers, you just have to bring down those names together. That is between angle P and angle Q, line segment PQ, that way. So that these things you need to remember, especially for MCQ point of view. We know that a triangle is a planar figure, so it obviously divides the given plane. A triangle always divides the given plane or its own plane into three disjoint sets. That is number one, that is the triangle itself. Then number two, that is the interior of the triangle. And whereas the last one, that is the exterior of the triangle. Let me tell you that these three sets, that is the triangle, interior of the triangle and exterior of the triangle, are disjoint sets. That means the intersection of a triangle and its interior, or else the intersection of interior and exterior, or else the intersection of triangle and the exterior, all of them are null set. What do we understand by the interior of a triangle? Supposing we are given three distinct non-collinear points P, Q and R in the given plane. Therefore, we obtain a triangle, that is triangle PQR. Now, the interior of the triangle will mean that it should be the interior of all the angles of the triangle. For example, if we represent the interior of angle P as I1, then interior of angle Q as I2, and lastly interior of angle R as I3, then the intersection of all the three sets, which is represented as I over here, that is referred as the interior of the triangle. That means we can represent it in a set notation like interior of triangle PQR I is nothing but I1 intersection I2 intersection I3, where I1, I2 and I3 are nothing but the interiors of angle P, angle Q and angle R respectively. But every time it is not necessary to take up the interior of all the three angles. We can have, or we can write down that interior of the triangle I can be represented as interior of only I1 and I2, that is I1 intersection I2. Similarly, I2 intersection I3 or I3 intersection I1, all of them means the same thing, that is interior of the given triangle. Exterior angle of a triangle. The angle which forms a linear pair with any of the angles of the triangle, that is considered to be the exterior angle of the triangle. Supposing we are given triangle ABC and we extend a ray such that we get B dash C dash D. That means you can see that angle ACD forms a linear pair with angle ACB. That means angle ACD and angle ACB form a linear pair, and therefore over here angle ACD is the exterior angle. Similarly, we can have angle BCE forming a linear pair with ACB once again, so that also forms an exterior angle. That means at each vertex we have two exterior angles. So at each vertex we have two exterior angles of the triangle, and in all there are 6 exterior angles for a given triangle. So how many exterior angles do we have for a triangle? 6. And how many exterior angles do we have at each vertex of the triangle? That will be 2. Interior opposite angles of the given triangle. The angles other than the angle other than the angle which is the exterior angle forming a linear pair, that is considered to be the interior opposite angles of that corresponding exterior angle. Supposing angle ACD is an exterior angle of triangle ABC. Now we know that over here angle ACD forms linear pair with which angle? Angle ACB. Then over here we will say that exterior angle is angle ACD, and that exterior angle ACD does not form linear pair with angle A and angle B. So angle A and angle B are the interior opposite angles for angle ACD. Theorem number 9.1. Now that relates with the measure of the exterior angle is always larger than the measure of its interior opposite angles. For example, for triangle ABC, if angle ACD is an exterior angle, then obviously the interior opposite angles are angle A and angle B for angle ACD. Then measure angle ACD will be greater than measure angle A, and also measure angle ACD will be greater than measure angle B. So theorem number 9.1 states that the measure of the exterior angle is always greater than the interior opposite angles. Theorem number 9.2. Now here it relates between the measure of the exterior angle is exactly equal to the sum of the measures of the interior opposite angles. That means for the given triangle ABC, if angle ACD is the exterior angle, then measure angle ACD will be nothing but equal to measure angle A plus measure angle B. So theorem number 9.2 states that the measure of the exterior angle is nothing but the sum of measures of its interior opposite angles. Let us see in example number 1, where angle PRS is an exterior angle of triangle PQR. So we are given a triangle PQR and angle PRS is the exterior angle. Line PQ is parallel to line YR, that is given to us, such that measure angle PRY is given to be 50. Y, as we can see, that it is in the interior of angle PRS. Measure angle YRS is given to be 70. We are expected to find out measure angle PRS and also the measure of each of the interior opposite angles. So Y is in the interior of angle PRS, and therefore we can say that measure angle PRS is nothing but measure angle PRY plus measure angle YRS. That is 50 plus 70, and that is measure angle PRS is 120. Now you can see that measure angle PRS, that is angle PRS, and angle PRQ, they do form a linear pair. And also we know that line PQ is parallel to line RY, and line PR would be the transversal. And therefore what do we know about the alternate angles? Angle P will be exactly same as angle PRY, and therefore this angle is also going to be 50 because of alternate angles. Also angle Q and angle P are the interior opposite angles for angle PRS, and therefore measure angle P plus measure angle Q will be same as measure angle PRS. Out of this we know P, and that is 50, plus Q, measure angle Q is 120. So measure angle Q is 120 minus 50, and that is 70. So we have found out the measures of the interior opposite angles. One of them is 50 and the other one is 70. So measure angle PRS, the three answers that we require is 120, measure angle P is 50, whereas measure angle Q is 70. Theorem number 9.3. The sum of measures of all the angles, all the three angles of a triangle, and you know that it is 180. Now we shall prove that why it is 180. So in the data part we are given a triangle ABC, and the thing that we need to prove is that measure angle A plus measure angle B plus measure angle C is equal to 180. Let us see how do we prove this theorem. So in the proof, first of all we require to have some construction. That is, let D be a point on the ray opposite to ray CB, and therefore that angle ACD is what? That is the exterior angle. So exterior angle ACD is formed, and that forms a linear pair with angle ACB, and because of that reason measure angle ACD plus measure angle ACB is going to be 180. Why? They are the linear pairs, isn't it? Let us remember this as statement number 1. So we proved up till now that measure angle ACD plus measure angle ACB is nothing but 180. Also we know that Angle A and angle B are the interior opposite angles for angle ACD, and therefore measure angle ACD, that is this measurement, would be nothing but sum of measure angle A and measure angle B. Let us remember this as statement number 2. Now, instead of measure angle ACD of statement number 1, if we combine statement 1 and 2, we can write down measure angle A plus measure angle B. So, that is what we will be writing down, that by statement number 1 and 2, measure angle ACB remains as it is. But instead of measure angle ACD, we can write down measure angle A plus measure angle B. So measure angle ACB plus measure angle A plus measure angle B is nothing but 180. That means measure angle C plus measure angle A plus measure angle B, or else we can change the order. Measure angle A plus measure angle B plus measure angle C is equal to 180, and that is what we wanted to prove. We need to understand an important result, that if one angle of a triangle is a right angle, then the other two angles will have to be acute angles. That means no triangle can ever have more than one right angle. So, the data part is angle ACB, supposing for triangle ABC is going to be a right angle. And we have to show that both angle A and angle B, the remaining angles, are acute angles. So, how do we show that? Let us see. For that, once again, we need to carry out some construction. Let D be a point on the ray opposite to ray CB. So, measure angle ACB and that is the exterior angle ACD, they form a linear pair. And that linear pair means measure angle ACD is a right angle once again. Why? Because we know that linear pair is supplementary. Measure angle ACB, we know that it is 90. So, if two linear pair or two supplementary angles, one of them is 90, other has to be 90. That means measure angle ACD is also a right angle. So, measure angle ACD is 90. Let us remember that as statement number 1. Now, for angle ACD, angle A and angle B are the interior opposite angles. And remember theorem number 9.1. What did it say? That the measure of the exterior angles is always bigger than the measure of the interior opposite angles. So over here we can say that measure angle A is less than measure angle ACD. And same way measure angle B will be also less than measure angle ACD. But what is measure angle ACD? That is 90. That means measure angle A is also less than 90 and measure angle B is also less than 90. An angle whose measure is less than 90, what do we call them as? They are acute angles, isn't it? So, angle A and angle B are the acute angles. In example number 2, for triangle ABC, measure angle A is going to be 40, measure angle B is going to be 60. And it is so easy to find out the measure of angle C. We know that measure angle A plus measure angle B plus measure angle C is 180. Substituting the values of A as 40 and B as 60. So measure angle C is going to be 180 minus 100. And so measure angle C is equal to 80. In example number 3, for triangle ABC, measure angle A is twice of measure angle B, whereas measure angle B is thrice of measure angle C. And we are expected to find out the measure of all the angles of the given triangle. So for triangle ABC, sum of all the angles, as we know that it is 180. So measure angle A plus measure angle B plus measure angle C is 180. But we know that B is thrice of C. That is already given to us, that measure angle B is nothing but 3 times of measure angle C. And therefore, twice of measure angle B is going to be 6 times measure angle C, multiplying both sides by 2. Now, why did I do that? Because in the one of the relations, we are given twice measure angle B. So instead of this twice measure angle B, we can relate that with measure angle A also. That means measure angle A is equal to twice measure angle B as it is given, and therefore measure angle A is equal to 6 times measure angle C. Now let us substitute all these values of measure angle A and measure angle B in measure angle A plus measure angle B plus measure angle C is equal to 180. So that is going to give us measure angle A, instead of that measure angle 6 measure angle C plus 3 measure angle C plus measure angle C. And that is 6 plus 3 plus 1, that is 10 measure angle C is 180. Means measure angle C is 180 upon 10, and you know that it is 18. We know measure angle C, so we can find out measure angle B very easily. That is 3 into 18, that is 54. And similarly we can find out measure angle A, that is 6 into 18, and that is going to be 108. So measure angle A, measure angle B and measure angle C, all of them we have found it out as respectively 108, 54 and 18. In example number 4, the measures of the angles of the triangle are in the proportion of 4:5:6. We are expected to find out the measure of all the angles of the triangle. Let triangle ABC, where measure angle A is to measure angle B is to measure angle C, as given over there as 4:5:6. Taking x as the common multiplier, so we can write down that measure angle A will be 4x, measure angle B 5x, and measure angle C would be 6x. And we know that measure angle A plus measure angle B plus measure angle C is 180. So what is that we will be doing now? Substitute the values. What else? Isn't it? So that is 4x plus 5x plus 6x is 180. A simple equation, and that is going to give us 15x is equal to 180. So x is equal to 180 upon 15, and that is equal to 12. So let us substitute the values of x in each and every one of them to find out measure angle A as 48, measure angle B 5 12s are because 5x, that is 60, and measure angle C, which is 6x, so 6 into 12, that is 72. So we have found out the measure of all the three angles, that is measure angle A, measure angle B and measure angle C respectively as 48, 60 and 72. In example number 5, for triangle ABC, the sum of measures of two angles is 60, whereas the difference is given to be 20. We are expected to find out all the angles of that particular triangle. So in triangle ABC, supposing measure angle A plus measure angle B, as given that sum is 60, we'll take it as 60. Whereas that difference is given to be 20. So measure angle A minus measure angle B is given to be 20. Now I'm expected to find out each and every one of the angles of this triangle. So what I'm going to do is I'm going to add up these two equations. That is, when we add up these numbers, measure angle A plus measure angle A, that is going to give us 2 measure angle A, plus measure angle B minus measure angle B, that will get cancelled, and plus 60 plus 20, and that is going to give us plus 80. So 2 measure angle A is 80, means measure angle A is going to be 40. Now by number 1, let us substitute in place of A as 40. So 40 plus measure angle B is 60. So measure angle B is 60 minus 40, that is 20. So we found out measure angle B as 20. Now to find out measure angle C, substituting the values of A and B, that is equal to 60 plus measure angle C is equal to 180. Because measure angle A plus measure angle B, we know that it is right from the beginning, it is 60. So measure angle C is going to be 180 minus 60, and that is going to be 120. So all the three angles, that is, are 40, 20 and 120. Now we are given a figure where measure angle A in triangle ABC is going to be 30, measure angle C is going to be 50, and the bisector of angle B, that is intersects line AC at point D. We are expected to find out measure angle ADB and measure angle CDB. If we find out one of these angles, the other angle, linear pair, can be found out very easily. Now it's not that difficult to solve this sum. We know two angles of the triangle ABC, that is angle A and angle C. So we can find out the third angle of the triangle, that is measure angle B. So let us see how do we solve this sum. Now measure angle A and measure angle C are given to be 30 and 50 respectively. And also sum of all the angles is how much? 180. So substituting the values, 30 plus measure angle B plus 50 is 180. So measure angle B is going to be 180 minus 80, that is 100. So we found out that whole measure angle B is nothing but 100. But some bisector is given and BD bisects angle B. And because of that particular reason, measure angle ABD will be measure angle CBD will be half of measure angle B, that is half of 100, and that is 50. So each of these angle is 50 and 50. Now let us see how do we find out one of the angles. Now in triangle ADB, that is the upper triangle ADB, we know two angles. One of them is 30, another we found it out as 50. So once again we can find out the third angle very easily by knowing that the sum of all the angles of a triangle is 180. But we know BAD as 30 and we know ABD as 50. So 30 plus 50 is equal to measure angle ADB. Is equal to 180. And therefore measure angle ADB is 180 minus 80. Therefore once again this angle is also going to be 100. What do you think would be measure angle BDC then? That is going to be 80, isn't it? Because it forms a linear pair with angle ADB. So measure angle ADB plus measure angle CDB is equal to 180 because of linear pair. So 100 plus measure angle CDB is 180. So measure angle CDB is equal to 80. So we have both the angles, that is angle ADB, measure angle ADB as 100 and measure angle CDB as 80.